Hello, everyone, and welcome to this AI demo where we are going to see an evolving AI ML solution. So let's dive into it. So imagine yourself, you're walking the corridors of a superstore, and in your handset, you can actually take a snapshot of a particular article and then check the price or see what's the offer on that day. Another example would be once you have done all the shopping, you go to the conveyor belt for the checkout and you put all the articles in it, and you have a smart camera there that is scanning all the products, identifying them, and then calculating the final amount you have to pay. So how do we construct all of this? So let's go through 4 very important stages I want you to go through. First of all, let's look at all the bits and pieces here on the left. So these are all IoT devices and users interacting with the platform. And the very first thing they need to do when you want to, let's say, onboard a new product to the catalog in the superstore, then you enter into the data acquisition phase. So basically, you want the staff to push training data and store it locally. So this is happening at the near edge where the store is, and ingest as much data as you can for the training. And once you have the full collection of training data for a particular product or a collection of products, then you're ready to push that to the main data center where the training is going to happen. And then we enter into phase 2, which is called data preparation and modeling. And well, the first thing that needs to happen is there should be a team of data scientists that are going to design and implement all the processes that meet the requirements and produce, the implementation for generating models for the shopper. And so, but when all of those are ready, then basically you can enter the third phase, app dev and delivery, where you just add some integration bits and some automation with OpenShift pipelines and GitOps. And basically, this is going to mechanize and automate the release of new versions of the model and new versions of the smart application, and so that they are ready to be pushed to the edge. And finally, on the fourth phase, then we have the live AI ML inferencing, where real traffic coming from users and shoppers are going to be firing traffic and then basically triggering inferencing to identify the information, to obtain price tags and pricing information, and so on. Right, so let's jump to the demo and let's see how all of that is built. So we jump to our environment where you see that we are in a namespace called Edge 1. This represents to be the shop space, and basically here the most important deployment is this one, the shopper application. This is the one that implements the smart application that can be used by the staff and users, and that is going to be interacting with the model server that is going to be in charge to execute the inferencing and recognizing all the products. And once you have a product, then the shopper can integrate with the pricing engine that has a catalog with all the pricing information you can fetch and then respond with and then pass to the users. All right, so let's see how that executes. So let's have a look to what this smart application looks like. So switching windows, what I want to show to you is, it's thinking a little bit, right? So on the foreground, we have this window, which represents the smart application that you can open on your phone as well, but we are opening here in a tab. And on the background, we have a monitoring view that is going to run some animations that are going to illustrate how the different systems are interacting between each other. And so the first thing we want to do is actually enter in detection mode to show you how it works. So basically, it opens the front view camera, and imagine I have this product. So this is a tea bag that I have. So this is green tea. I could take a picture here and then just run an inference and run it. And instead of doing using this photograph, I'm going to just pick a file from my machine, which is the same tea bag, but I want to do this because I want to reuse the same image later on, and you'll understand why. So I'm going to send this via MQTT, which is a well-known protocol for IoT. And when I do so, you'll see that I'm going to fire an event. So let's go and click it. So when I do, you should see an event that is picked up by Camel, pushed to run an inference, but it's found invalid and then pushed to the unclassified data bucket. The reason for that is that this, TBAG, this product, is actually not known to the model that we have preloaded. So this version 1 model only understands about two different articles, two other types of T, but not this one. We haven't trained this particular article, this TBAG, this type of T, for the AI engine to actually recognize it, right? So let's just run a positive test case so that you see what I mean. If I open this other file, so for example, this T all gray, I open it, and then you'll see that the image loads there. I can just zoom in. You see that it's an Earl Grey tea box, yellow box that I had at home, and basically I took pictures and I trained the model that is right now deployed on the AI engine. Right. So when I fire this, let's see what happens now. An event goes by the broker and then is pushed to the AI engine. This time it finds it valid, and we have a $3.99 price tag for the product, and then that's pushed to the training data. All right, so we run, a negative test, a positive test, so that you see that there are current products in there, and there are others that are not. Right. So the next phase, basically, what we need to do is to really train the new product. And for that, let me just very quickly open Red Hat OpenShift AI. So this would be the environment where data scientists work. And here we have a project that is already pre-deployed as well. And we should see there an already running workbench that I can open. And this is going to open Jupyter Lab. So Jupyter Lab is where data scientists can work on the notebooks. So notebooks are these pieces of code where data scientists combine Python with AI libraries, in this case TensorFlow, and they can create all the functionality that it is required. They also produce a workflow to actually, mechanize and automate this. And you see that there are 3 steps here. And basically, they compose this by just simply dragging and dropping these activities in here. I'm not going to do it because it's done already. But basically, this first step, you see that it's about loading training data. So this is going to find a bucket, is going to download all the images, and then that will allow the second step to actually do the real training. This is the one that produces a model, and once a model is available, then the third one is going to push this to another S3 bucket so that then it can be fetched by the edge and then hot deployed in the edge environment in the shop. Right. So they are going to build these workflows, and from here, then we can click this button that says Export Pipeline. And what this action is going to do, it is going to take this graphical workflow and translate it into an OpenShift Tekton pipeline in a YAML definition, right? And with that YAML definition, then we can go to OpenShift and import it. And let me show you where we have done this. So if we click here, pipelines, and then I choose the namespace where the pipeline is included, you see that it is there in green. It is green because I did execute this earlier just to check that it was ready for the demo. But if I look a little bit more in detail, you see that it has the 3 steps that we've seen on the graphical view. So basically, this is the pipeline that we want to trigger once we are ready. All right, so let's go back to this view. So what now I'd like to show to you is the how we are going to train these, but for this we need training data, of course. And so this view here actually looks at the S3 bucket that will contain all the training data. And what you can see is that at the moment it is empty. We have no training data. So basically, we need to generate the training data in order to include a new product in the catalog. So let's do that. I want to show you how we do that. And basically, we go back to this view. And then what we do is we go back to the smart application, and it has another button that says enter in ingestion mode. And this is to generate training data. So I can click on that. And you see that it's already pre-configured to train this type of product. So the user just selects this type of product and clicks OK. Then it could take the product that needs to be trained. In this case, it will be the tea bag. And then we can take a picture. If I put it on the front of the camera, I take a picture. and then we could push it to the system to actually ingest this as a training data. But what I want to do instead is to use my smartphone. So I'm going to use the smart application so that you see how it is done. So let me just very quickly open it. You see that I have here the same application. I'm going to enter ingestion mode. I'm going to select the same training data, so green tea, which is Bali tea, and then all I'm going to do is, take a picture of it on my desk. And when I do so, I'm going to take a picture, and now I'm going to push it to the system. And you should see an event when I send it. Here I go. So I click send, and you see an event that is picked up by Camel and goes directly pushed to the training data. Right, so we have one image already available in the bucket, but of course we need tons of data. And well, unfortunately for this recording, we don't have a live audience that could join us or staff members. But then what we do is we simulate that there's staff and people that actually are going to generate that data. So I have a script for that I'm going to trigger now. I'm going to say sim audience, I launch it. And if we go back now, we see this very nice illustration and animation where we see plenty of events coming in, simulating they come from a device, because what a staff member would need to do is to take the product, take pictures from all angles, from the top, from the side, from the back of the product, and push it to the system to generate hundreds of images. The more images, the better. And so that the model, it is accurate enough. Of course, with a live audience, this would be a lot more fun, because you make them, you give them the application, they can play with it. You give them a nice product and a nice little tea bag or something. They can take pictures and they interact with the live system. Also, it's fun because you can tell them that make sure you don't take random pictures, otherwise, you are going to introduce inaccuracy in the model, and then that might break the demo. But okay, all in all, this is going to finish soon. We have around 100 images. This is actually a replay from images we gathered on a live session. And so just to show you that we have the pictures now in place, I'm going to refresh this view, and then we should get the pictures. And let's see. Oh, there they come. So the very first picture you see is the one I took with my phone on my desk. So that's the picture I pushed. And all the others are the ones that we have pushed with the script. And so, like I say, all these pictures are real. These were taken with a live audience, so it was a lot of fun. And all right, so now we have a good bunch of images. And what we can do is initiate the training. So I'm going to click here on this button, train data. And when I do so, then you will see on this animation how there's a Camel integration that is reading all the files from the S3 bucket and packing all of those into a zip file that then is going to be pushed over the wire via a secure connection with Service Interconnect that is picked up by another integration point on the main data center and pushed to a local S3 bucket. Then it kicks off the Tecton pipeline, and you see that the very first thing it does, it reads all the training data, and the real training starts happening. Right, so this is when that graphical workflow we saw earlier is in execution, and will take a little bit of time. And I want to show to you that this is actually happening for real in the system. So I'm going to go back, and you see here that we have the pipeline that actually has just completed the first stage, and now it is completing the second stage, which is the real training. And I'm going to superpose that with our view from earlier. And well, okay, so this is going to take a little bit of time. And while normally in other AI demos you might have seen, probably they already had version 2 ready, because of course this is the phase where training data is very CPU hungry. You need hundreds of images. It takes a lot of time, and generally you cannot show this, but we can today. So this is a real AI training that we are doing, and we can do this because we have shortened the time considerably, because we are using a technique that is called transfer learning. And with transfer learning, what we are doing is we are reusing a well-known AI model that there's out there for image recognition, and we are keeping most of the functionality to recognize, the features of an image. So edges and the brightness, colors, and so on. And the only thing so we are keeping most of it. And the only thing that we are doing is stripping the very last layers of the neural network. And then we are reconstructing the last layers with our training data, and we are adding that to the very end. And that's why we are shortening the training process quite substantially, because we don't need to train the whole model. And you see that now it is entering into the last phase. It has completed the training, and now it's going to push the new model. And we should see that on the animation there, how the new model is pushed to the buckets. And once it is in the bucket, it can be fetched by the edge, as you can see. And then it is hot deployed on the AI engine, which then now would be running on version 2. Version 2 is the one that now knows about this new product, the new tea bag we have trained. And so, okay, let's prove that. Let's just go back to our application here, and we enter again into detection mode, and I'm going to open the same file that we had earlier, just to the one that was failing, that was not able to recognize. So if I open this and now I send it, let's say, via HTTP, the result we get, let's have a look to that. The event then goes to the AI engine, and it finds it valid, and we find a price tag of $249, and that is placed on the training data. Now, the $249 is a configuration that was already prepared for the demo, so we haven't done it live, but it was already in place. The only thing that we needed to do is to train the new model version. Well, with that, we have seen how successful it was, the training, and now we have the product that it is recognized by the system. And just to recap a little bit, what we have seen is a bunch of technologies with Service Interconnect to connect both environments, integration with Apache Camel, automation with pipelines, and many other technologies that allow us to have this continuous circle to generate and ingest training data for a new product, produce a new model that can be released and pushed to the edge environment, and that is hot deployed without any service interruption. And of course, users can always do the live inferencing and obtaining all the data. Now, if you have liked this demo, you can find all about it and a lot of more information in this page, Solution Patterns Catalog, where it is included. You'll find many other patterns as well, but if you go to this website, solutionpatterns.io, then you'll find this one included there, and please explore all the other patterns as well. Thank you very much for listening, and hope to see you soon. Bye.